Today I am going to continue the chapter Electricity of the subject Science and Technology of class 9, and this is taken in unit 11 and this is part 3. Part 1 and part 2 we have done previously. Now I am starting part 3. In this part actually we are going to establish the relationship between the potential difference and current. Just think about this. We are going to establish the relationship between what? PD, potential difference, and current I. Potential difference is symbolically represented by V and current symbolically represented by I. We are going to establish the relationship between V and I. But for this, at first we have to recall what is V, I mean to say what is potential difference, what is current, and what do you mean by 1 volt potential difference, and what is the meaning of 1 ampere current. First we have to understand these terms and then only we will be able to establish the relationship between the potential difference and current. Okay, let's start with potential difference. What is it? It was told in previous class also. Work done or energy conversion between 2 points of the circuit by the flow of a unit charge is known as potential difference between those 2 points. It is denoted by V and its SI unit is volt, V. It means if someone says the potential difference V equal to 5V, it means first V represents potential difference and second V represents its unit volt. Okay, it is represented by this formula. Potential difference V equal to work done W by charge Q. Now, if you remember what I told you in previous class also, I am repeating the same thing. This is an electric circuit, and if we have to measure potential difference between 2 points of the circuit, I mean to say the left hand side one point is taken, right hand side another point is taken, we are going to find out the work done between these 2 points. Then certainly we will use voltmeter, and voltmeter should be connected in such a way that the wire connected to negative terminal of cell or battery should be connected to minus wire connecting point of voltmeter, and wire coming from positive terminal of cell or battery should be connected to plus symbolized wire connecting point of voltmeter. This way we measure potential difference between 2 points of the circuit, and what amount of electrical energy converts to another form of energy in between these 2 points when 1 coulomb charge flows from this point to this point is being measured, and this is PD between these 2 points. Okay, now what is 1 volt PD? And this can be defined this way. Potential difference between any 2 points of a circuit is said to be 1 volt if 1 joule work is done or 1 joule energy conversion takes place by the flow of 1 coulomb charge between those 2 points. 1 V equal to 1 joule by 1 coulomb. Probably you feel a little difficulty to understand this. I want to represent the same with the diagram. Look at this. This is the measurement of potential difference between these 2 points. When 1 coulomb charge flows from this point to this point, and if 1 joule of work is done between these 2 points, then potential difference between these 2 points is said to be 1 volt. Because 1 joule of energy conversion if takes place by the flow of 1 coulomb charge between 2 points, then PD between those 2 points is said to be 1 volt. Okay, I told you about potential difference and 1 volt potential difference. Now let's talk about current, because we are going to establish the relationship between the potential difference and current. So we must know what is current and what is 1 ampere current, then only we will be able to establish the relationship between the potential difference and current. Okay, what is electric current? It can be defined this way. The rate of flow of charge or the flow of charge in unit time is called current. What amount of charge flows in the conductor in 1 second time, that represents the current, and it is measured in ampere, and its formula is current equal to charge by time. It can be understood very easily by this video clip also. Let's say electrons are flowing It means electrons are carrying negative charge, and this negative charge is crossing, let's say, this cross section of the conductor. Then amount of negative charge crossing this cross section can be taken in numerator, and how long it takes to cross that cross section, that is time. If the amount or total amount of charge crossing this cross section is divided by time taken by those charges to cross this cross section, then we'll get current, and current comes in ampere. Okay, now what is 1 ampere current? We can define this way. Let's say this is a conductor wire and current is flowing towards this direction. Flow of current means certainly electrons are flowing in this conductor, and let's say this is a cross section, and it can be magnified in the same way what I had shown in previous slide. Look at this. How many electrons are crossing this cross section in 1 second time? Now, if one coulomb charge contained in the electron, if one coulomb charge crosses the cross section of this conductor in 1 second time, then flow of current is said to be 1 ampere. We can define this way. When one coulomb charge crosses a cross section of a conductor in 1 second, then the flow of current is called 1 ampere. And formula for this 1 ampere, mathematically it can be represented by this way: 1 ampere equal to 1 coulomb by 1 second. Okay, what I told you, PD, potential difference, current, and 1 ampere current and 1 volt potential difference. Now it's time to establish the relationship between potential difference and current. Now I am going to show you an experiment. With the help of this experiment, we are going to establish the relationship between potential difference and current. Okay, what is experiment? Let's say we have a cell, and cell is connected to a bulb. Now after connecting this, now what happens? Current flows from positive terminal to negative terminal. We know this. Now if emitter is used in the circuit in series, this emitter is connected in series, because the current which flows through this bulb is also flowing through this emitter. It means emitter is connected in series. If we connect emitter in series, then it measures current which is flowing through this bulb. But emitters should be connected in such a way that the wire coming from positive terminal of cell should be connected to plus symbolized wire connecting point of emitter, and like that wire connected to negative terminal of cell should be connected to minus symbolized wire connecting point of emitter. Now this emitter measures current in the circuit, and if a voltmeter is connected like this type of connection is called parallel connection. Emitter is always connected in series, but why voltmeter is used here? To measure the potential difference between these 2 points. I mean to say, potential difference across this bulb is being measured, and it should be connected in such a way that wire connected to positive terminal of cell or battery should be connected to plus symbolized wire connecting point of voltmeter, and wire coming from negative terminal of cell or battery should be connected to minus symbolized wire connecting point of voltmeter. Now what we did, actually current is being measured and PD across the bulb is being measured. 2 physical quantity we are going to measure. One potential difference, another current, because we are going to establish the relationship between potential difference and current. Now I want to show you another electric circuit. What is the difference between these 2 electric circuits? All other components are same, but in place of 1 cell, now I am using 2 cells. Look at these 2 cells. Certainly value of current will be different than the first circuit, and certainly value of potential difference will also be different if we compare it with first circuit. Now we are going to note down the value of current and potential difference in this circuit, in case of this circuit also, and in case of this circuit also. And next diagram, look at this. What is the difference between this circuit and other circuit? All other components are same, but 3 cells are used. In first circuit, one cell is used. In second circuit, two cells are used. But in third circuit, three cells are used. Now certainly the value of current is different than first and second. And certainly value of potential difference will also be different than first and second. Actually, what we are doing from the beginning, what I am saying, we are going to establish the relationship between the potential difference and current. This experiment was done first by the person called George Simon Ohm. And this is a person, this was the scientist who first established the relationship between the potential difference and current, and now we are following him. And according to his experiment, what he got, we are going to verify the same thing. That's why I want to now make a table and what was our observation of the previous circuit, what was the value of current, what was the value of potential difference. We are going to tabulate all of them. Look at this. First column, number of cells. First we used one cell, second we used two cells, third we used three cells. And when one cell was used, what was the value of potential difference? And when two cells were used, what was the value of potential difference? And when three cells were used, then value of potential difference, all noted down here. If we note down all these value here, and when one cell is used, value of current, two cells is if used, value of current, and three cells when used, value of current is if noted down, then what is found? When potential difference increases in the circuit, current is also found to be increased. It means these two quantities are directly proportional to each other. When one increases, another also increases. This was first declared by Ohm. Potential difference is directly proportional to current. And if we calculate the ratio of potential difference and current, and what was found, the ratio of potential difference and current V and I, ratio of V and I is found constant in this first case also when one cell was used, in second case also when two cells were used, and when three cells were used. In all the cases, what was found? The resistance, the ratio of V by I, named as resistance, later I will talk about the resistance in detail. The ratio of V by I was declared as resistance, and resistance is found same. It means the resistance is same, but ratio of V by I is equal to resistance, and potential difference is directly proportional to current. And the declaration of Ohm was taken as Ohm's law. And now I am going to present Ohm's law. What is it? According to Ohm's law, when physical conditions and temperature remains constant, the current flowing through a conductor is directly proportional to the potential difference between two ends of the conductor. Very interesting. It was first declared by Ohm's law. Ohm told that the potential difference is directly proportional to current. But have you noticed this? When physical condition and temperature remains constant, what it means? We do not have to change the physical condition. In previous circuit, what I did, using one cell, which bulb was used in the observation, when we use two cells, the same bulb should be used. We cannot change the bulb. And when three cells were used, at that time also the same bulb should be used. Physical condition should be same, because the bulb has got one filament inside it, and length of the filament is if changed, it means physical condition is changed. If bulb is changed, then power is changed, it means physical condition is changed. Physical condition should be same. And sometimes if we use hot wire in the experiment, sometimes if we use cold wire in the experiment, then probably our result will be different, what is told by Ohm's law. So physical condition and temperature is if same, then potential difference is directly proportional to current. This was very important information of Ohm, and it is taken as Ohm's law. Is it correct? I want to verify this with experiment, and I have taken an ammeter, a voltmeter, and a bulb and a switch also, what was shown in the circuit, and I want to show it. I mean to say, when current increases, potential difference also increases or not. I want to show it. Okay, look at this experiment. First, I want to show the connection. Here we have voltmeter and ammeter, and actually this bulb is connected to ammeter and there is switch also. If I connect the cell positive terminal with this plus symbolized wire connecting point and negative terminal with this, then the cell, bulb, switch and ammeter, this makes an electric circuit. Yes, cell, bulb is connected to bulb and there is switch also, and ammeter is used in series to measure the current which is flowing through the circuit. And here voltmeter is also connected. It is connected to left hand side and right hand side of this bulb. I mean to say, the potential difference between these 2 points is being measured. Potential difference across the bulb is being measured. Okay, now I want to turn this towards you because I want to show the value. Okay, now this is the wire coming from negative terminal. That's why I am going to connect the negative terminal of this cell at this place, and I am going to connect this positive terminal of the cell here. The wire coming from positive terminal of ammeter is connected to plus symbolized wire connecting point, and wire coming from the negative terminal of the ammeter is connected to minus symbolized wire connecting point. When we connect correctly and if we switch on the circuit, then look at this. Bulb is glowing but very less amount of energy is being converted, and there is value in voltmeter 3 or 4 lines, and here it is about 5 lines. Now when I use one cell, then this is the value of potential difference shown by voltmeter and this is the value shown by ammeter. But instead of using one cell, if I use 2 cells, then what is the difference? Let's see the difference when 2 cells are used. I am switching off the circuit. When 2 cells are used, look at this. Potential difference is found to be increased clearly in voltmeter, and in ammeter also not only 5 lines, it is more than 5 lines, 6 or 7 lines are shown by the ammeter. Now if we use 3 cells like this, when we use 3 cells, now look at the value. Now ammeter is showing about 10 division, but voltmeter is showing more than the previous. It means when I used one cell, the amount of current was less and potential difference was also less. And when I used 2 cells, both of them increased, and when I used 3 cells, then again both of them increased, and the lighting of the bulb is also being brighter and brighter because the energy conversion in the bulb per coulomb charge is being increased. PD across the bulb is increased. Okay, now what I proved just now, when current increases in the circuit or PD increases in the circuit, then current also increases. Current and potential difference are directly proportional to each other, but we must be careful that the physical condition and temperature remains same, should be same. I didn't change anything. The length of the wire is not changed, the bulb is not changed, temperature is not changed. Physical condition and temperature when remains same, then potential difference is directly proportional to current. V is directly proportional to I. This can be represented graphically also this way. Look at, this is y-axis and this is x-axis in the graph, and in x-axis we have taken potential difference. We are increasing potential difference by using more and more cell. Instead of 1, 2 cells are used, and instead of 2, again 3 cells are used. When potential difference is increased, then the current is also found to be increased, and we will get this type of graph. This is the graphical representation of Ohm's law. Okay. Now I think you are clear about the potential difference and current and how are they related, and what is Ohm's law also I made you very clear. There is one famous question, always it comes, frequently it comes in different examination also, and it is in your book also. If you are told this question to prove V equal to IR, then how can we prove this? This is established by Ohm, and that's why this is the equation obtained from Ohm's law. And V equal to IR, how can we prove this? First we have to mention Ohm's law. According to Ohm's law, when the physical conditions and temperature remains constant, the current flowing through a conductor is directly proportional to potential difference between 2 ends of the conductor. This is Ohm's law. And after the representation of the Ohm's law, mathematically we can write the gist of this law, that is V is directly proportional to I symbiotically. Yes, V potential difference, I current. Now if two quantities are proportional, then there must be a constant between these two quantities, and if we convert this proportional sign into equal to sign, then we can get an equation, but the equation must have that constant. We can convert proportional sign into equal to sign if we take the constant which involves between V and I. This way, V equal to Ri. Here R is constant and it is called electrical resistance, and it is given V equal to IR. That's why finally I want to write the same, V equal to IR. This way we can prove this, very easily proved, but the story behind this is very important. How potential difference increased with the increase of current. It was very important experiment. Okay, now it's time to talk about this resistance. I told you about V also, I also, but resistance is new term. Just now we decided that R is constant. The ratio of V and I is called R. It is a constant. And how can we define this constant? Electrical resistance can be defined this way. The obstruction offered against the flow of current by a conductor is called its electrical resistance. It is measured in ohm. I want to explain this later, but before this we have to understand another matter very clearly. If we have a copper wire and current is made to flow through the copper wire, it passes very easily. The obstruction of the copper wire against the flow of current is negligible. In the same way, if we use aluminum wire and current is passed through it, then again current passes very easily. Obstruction against the flow of current is negligible in case of aluminum also. But if the same wire is of iron, then it obstructs a little more than the copper and aluminum. If the same is tungsten wire, then obstruction is very huge. And because of the huge obstruction, the electrical energy which is flowing through this tungsten wire is obstructed in such a way that it becomes white hot. And that's why to convert the electrical energy into light energy, we are using this tungsten wire in electric bulbs. The obstruction against the flow of current by different metal is different. Different metals have different resistance, and because of this the resistance of different material is declared. And how can we define this resistance? This way, the obstruction offered against the flow of current by a conductor is called its electrical resistance, and it is measured in the unit ohm. In the name of the scientist Ohm, unit of resistance is taken as ohm. Now it can be understood this way also. Look at this. Let's say this is a conductor wire Electrons are flowing through this wire, and these electrons are flowing from one atom to another and from that atom to another, and the electron repels the electron of another atom. In this way, electron flows from one end to the another end. In this flow of electron, actually the same flow is different in different metals. In some metals it flows very easily, in some of the metals it flows very difficultly. I mean to say, in some of the metal resistance is high, that's why the flow of electron is not easy. In some metals this resistance is very less and flow of electron is very easy. Okay, now after this, what is 1 ohm electrical resistance? We know that resistance is measured in ohm. Then what is 1 ohm? 1 ohm can be defined like this. Electrical resistance of a conductor is said to be 1 ohm if the potential difference between its two terminals is 1 volt with the flow of 1 ampere current. What it mean? It means very simple matter. If PD between two terminals of a conductor is maintained 1 volt and flow of current is 1 ampere, then the resistance of that conductor is said to be 1 ohm. And mathematically 1 ohm is symbolized by this symbol omega, and this 1 ohm is equal to 1 volt by 1 ampere. Now I think you are clear about potential difference also, current also, and resistance also, and the relation between potential difference and current was established. In the meantime, resistance also came, and that's why I defined resistance exactly what it is. Now it's time to go through a question. Yeah, we know something about the potential difference, something about current, and the relationship between them also, and we know about the resistance also. Let's have a question related to this different physical quantity. Okay, a statement is written here. According to Ohm's law, when the flow of current is increased in a conductor, the potential difference between the two terminals of the conductor also increases. Just think about this. This statement is correct or not? And there is one argument over it. What is this argument number 1? Resistance increases in the circuit with the increase of potential difference. Is this correct? Just think about this. Take a little time. Now there is another argument also. Conversion of energy increases in the circuit with the increase of potential difference. Statement is given and two arguments are also given over the statement. Now we have to select which option among these is correct. Statement and argument 1 are correct. Argument 1 and 2 are correct. Number 3, statement and both the arguments are correct. And number 4, statement and argument 2 are correct. Now we have to select one of the option. Which option is correct for this statement and argument? Now let's check it out with the help of this 1, 2, 3, 4 options. In first option, statement and argument 1 are correct is told. Let's check statement. According to Ohm's law, when the flow of current is increased in a conductor, the potential difference between the two terminals of the conductor also increases. Long sentence, but the gist of the sentence is I is directly proportional to V. Current is if increased, potential difference also increases, means this is correct. Potential difference increases with the current and current increases with the potential difference, and this is Ohm's law, and that's why this is correct. Okay, option number 1 statement is correct, but here another point is also given. Argument 1 are correct. What is 1? Argument 1, resistance increases in the circuit with the increase of potential difference. What do you think? Is this correct? No. resistance of certain resistor or the filament of the bulb remains same whether you are using 1 cell or 2 cell or 3 cell. Resistance of that conductor, I mean to say that resistor remains same whether you are increasing potential difference or decreasing potential difference. That's why resistance increases in the circuit with the increase of potential difference. This argument is not correct. So we'll cancel the option number 1 because half of the part of this option is correct, or half of the part of this option is incorrect. So as a whole, this number 1 is cancelled. This is not the correct option. Now let's go to 2. Argument 1 and 2 are correct. Is it correct? Just now I told you the argument 1 is incorrect. Then why should we go through argument 2? Both are correct is told here. If one is incorrect, then we'll cancel this option number 2. This is also not correct. Now look at number 3. Statement and both the arguments are correct. What do you think? This is also incorrect. Statement is correct, we declared this, but both the arguments are correct told here, but first argument is not correct, previously decided. That's why option number 3 is also not correct. So it is cancelled. Now certainly number 4 should be correct. Statement and argument 2 are correct. We haven't seen this argument 2. Conversion of energy increases in the circuit with the increase of potential difference. Yes, just before this in the experiment what was seen, when we use more number of cells then potential difference was found to be increased, and at that time ball was glowing more brighter and brighter. What it mean? Conversion of energy, electrical energy into light energy was increasing with the increase of number of cell, means potential difference. That's why this argument 2 is correct. Statement is correct, argument 2 is correct. So we have to tick this option number 4. Okay, now after this question we have to go through the numerical problem also. After all, we got a formula, an equation V equal to IR. Why don't we use this to solve the numerical problem? This is also important part of this electricity chapter. That's why I want to present one question, numerical problem. If the potential difference across a resistor of resistance 30 ohm connected to a battery is 6 volt, calculate the electric charge and number of electrons which flows through the resistor in 10 seconds. Look at this question. While reading the question, someone can say that this is difficult, but actually when we write the information given in the question, then it becomes very easy for us. Okay, I'm going to write the information given in this numerical problem. Look at this. What is given first? Potential difference across a resistor of resistance 30 ohm. Resistance is given R equal to 30 ohm. And secondly, what is given? Connected to a battery is 6 volt. PD is found to be 6 volt. PD across the resistor, that is denoted by V, is 6 volt. Now what is another information? Calculate the electric charge. Electric charge we have to calculate, and number of electrons. There are two questions. Which flows through that resistor in 10 seconds. 10 seconds is time. Time is given 10 seconds. And what was the question? Electric charge. Electric charge is denoted by Q. Q is equal to question mark. And second, number of electron. Electron can be denoted by E minus. Number of electron is what? Now this is mathematical representation of this question. Now we don't have to see the question. We can go through this mathematical informations. Okay. What we are going to calculate? Q. But directly we cannot calculate Q. First we must have current and then we'll be able to calculate the charge. How to find the current? With the help of V and R we can find the current. We have we are going to find first current V equal to IR, and certainly I is equal to V by R. Now if we take the value of V, this is 6 volt and resistance is 30 ohm, then 6 ones are 6, 6 5s are 30, then current is equal to 1 divided by 5 means 0.2, and the unit of current is ampere, that's why I am writing A. Okay, current is 0.2 ampere, but this is not the question. We have to find out the Q. So what formula can be used? Again, I equal to Q by T. Now if we write 0.2 ampere in place of I and Q we are going to calculate, and time is given 10 seconds, then when 10 seconds is taken to left hand side, then what we get, 0.2 ampere into 10 seconds, this is equal to Q. Therefore Q is equal to what? 10 multiplied by 0.2 becomes 2. And what is the unit of Q? Q means charge. Charge is measured in coulomb. Okay, now we got one answer of the question, that is charge is 2 coulomb. Okay, now we have to calculate the electron also. Now how do we calculate electron? 1 coulomb charge contains 6.24 into 10 to the power 18 electrons. If it is so, this is the information. We got this information in previous class also. 1 coulomb charge contains this much electron, or this much proton contains 1 coulomb charge. This much electron, this amount of electron or this amount of proton contains 1 coulomb charge. That's why here our result is 2 coulomb. That's why 2 coulomb. Therefore 2 coulomb charge contains 2 into 6.24 into 10 to the power 18 electrons. And if we multiply, 4 2s are 8, 2 2s are 4, 6 2s are 12, and point comes here, into 10 to the power 18 electrons. But we know that we have to put this point after one digit. That's why I'm taking this point after one digit. It means 1.248. If the point is taken or shifted to one digit left hand side, then we have to multiply this with 10, or 10 means 10 to the power 1 into 10 to the power 18 electrons. Now this is equal to 1.248 into 10 to the power 1 plus 18 becomes 19 electrons. And this is the final result. What amount of electron flows in 10 seconds? 1.248 into 10 to the power 19 electrons flows within 10 seconds. Okay, I think we finished our target. I mean to say, we achieved our target. Now you are able to establish the relation between potential difference and current. Now you are able to say what is Ohm's law, and you are able to give example also. You can do this experimentally also, I hope so. Now our time is finished. That's why this much for today. We'll meet in another class with more information. Thank you.